For thousands of years, we've looked at massive stone monuments and assumed one thing: someone found a huge block of rock, cut it, shaped it, and somehow moved it into place. But there's a problem with that assumption, because more than a century ago, American builders were already doing something very different. They weren't simply cutting stone, they were manufacturing it. And the strange part is that the technology wasn't hidden. It was advertised, it was documented, and it was being sold to American architects as a modern building material. In 1920, the American construction magazine American Builder published material about cast stone and companies producing it. One issue even reported that the Bangor Cast Stone Products Company in Maine had released a catalog explaining its cast stone system and showing houses built from cast stone. And this wasn't some obscure experiment. American manufacturers were openly promoting artificial stone as a practical construction material. There were advertisements for materials designed to create stone-like surfaces. Some were even described as having granite-like density. So the idea was already established. Stone didn't always have to be carved from a natural block. It could be manufactured. But what exactly did they mean by cast stone? It wasn't necessarily molten rock. Instead, crushed stone and other aggregates could be combined with a binder and placed into molds. The material could be pressed, tamped, poured, or vibrated into shape. After curing, it became a solid architectural material. Columns, window surrounds, cornices, balustrades, decorative stonework, and sometimes entire architectural elements. The National Park Service documents this history of cast stone in America. So by the beginning of the 20th century, American builders already understood something that sounds surprisingly modern. You could take stone material, put it into a form, and create something that looked like natural carved stone. But there's another technology, and this one really does involve melting rock. Certain volcanic rocks can be heated to extreme temperatures until they become molten. Basalt is one of them. Industrial cast basalt is produced by heating crushed basalt to roughly 1,300 degrees Celsius, pouring the molten material into molds and allowing it to cool under controlled conditions. In other words, real rock can become a liquid, and then it can become a solid object again. A furnace, crushed rock, extreme heat, molten material, a mold, cooling stone. The technology is real, and once you understand that, an ancient question starts to look very different. So why does this matter? Because now imagine taking the same concept back in time, not necessarily to the pyramids, not yet. First, think about the manufacturing problem. If you quarry a giant block, you have to remove it from the mountain. You have to transport it. You have to move it into position. And if the block needs a complicated shape, you have to carve it. But if you manufacture a material near the construction site, the problem changes. You don't necessarily move one enormous object. You move the ingredients, you prepare the material, you place it into a form, and you let the material become the object. That's a completely different construction philosophy. And now we can finally go to Egypt. The Great Pyramid of Giza was built primarily from limestone, with granite used in important internal areas, and there is abundant evidence for ancient Egyptian quarrying. We know where some of the stone came from. We know the Egyptians worked enormous quarries, and we even have unfinished monuments that preserve their working methods. The unfinished obelisk at Aswan is one of the clearest examples. It was never completed, and because the project was abandoned, the quarry itself became a snapshot of ancient stoneworking. Tool marks, cutting trenches, unfinished surfaces, a gigantic piece of granite still attached to the bedrock. This is powerful evidence for conventional stoneworking. And it creates an obvious problem for the casting hypothesis. If the Egyptians could quarry and shape enormous blocks, why would they need to manufacture them? That's the question we have to take seriously. But now look at the finished monuments. The Great Pyramid contains millions of individual stone blocks. Some are rough, some are highly finished, some were hidden inside the structure, others were exposed. The outer casing stones were prepared much more carefully, and this raises another possibility. Maybe there was never just one technique. Maybe ancient builders used whatever method worked best for each job. quarrying, cutting, grinding, polishing, mortar, and perhaps, in certain circumstances, artificial stone. That's a much smaller claim than saying the pyramids were made from poured rock. And it's also much easier to test. Thousands of miles away, another set of ancient structures creates a different kind of mystery, Puma Punku. The site contains enormous blocks of andesite and other stone, including famous H-shaped elements with remarkably geometric profiles. Their surfaces contain straight edges, recessed sections, and carefully arranged angles. The conventional explanation is straightforward. Ancient builders were extremely skilled stoneworkers. They quarried the material, transported it, and shaped it using tools and abrasives, and there is evidence for ancient stoneworking across the Andes. So again, we have to be careful. Precision does not automatically mean casting. A strange-looking block is not proof of a mold, and a perfectly fitting joint is not proof of artificial stone. But it does give us something worth investigating, the surface itself. Because the stone itself may be able to tell the story. If a block was manufactured rather than quarried, we should expect evidence, maybe in its chemistry, maybe in its microscopic structure, maybe in the distribution of minerals, maybe in the presence of a binder, maybe in the way crystals formed as the material cooled or hardened. And scientists have actually looked for these clues. One of the best-known proponents of artificial stone in ancient Egypt is materials scientist Joseph Davidovits. His geopolymer hypothesis proposes that some limestone material could have been chemically reconstituted rather than simply carved from a natural block. But there is an important problem. Other researchers continue to find strong evidence for natural limestone and conventional quarrying, and mainstream archaeology does not require artificial stone to explain the construction of the pyramids, so we are left with a genuine disagreement. Not between science and mystery, but between different interpretations of physical evidence. And maybe the wrong question is, were the pyramids cast? That's too broad. The better question is, can we identify individual ancient stones that were manufactured rather than quarried? Because if the answer is yes, we don't need to rewrite all of ancient history. We only need to add another technology to the toolbox. But here is the problem. Where are the ancient molds? Where are the large-scale mixing facilities? Where are the remains of the furnaces? Where are the distinctive waste products? Where is the unmistakable chemical fingerprint of manufactured stone? These are not minor objections. They're the biggest problems with the theory. And until those questions are answered, we cannot honestly say that the Great Pyramid was built from cast stone. We can only say something much more interesting. The technology itself is real. Humans have manufactured stone-like materials for centuries. Humans can even melt certain rocks and cast them into new shapes. And ancient civilizations were capable of extremely sophisticated stone engineering. So perhaps the mystery isn't whether ancient people were capable of doing something like this. Perhaps the mystery is whether they actually did. Imagine finding an ancient block. You analyze the chemistry, you examine the crystals, you study the microscopic structure, you compare it with the local bedrock, and then you discover something unexpected. The block isn't quite the same, not because of weathering, different because its material history is different. That would change everything. Because suddenly the question wouldn't be, how did they move this block? It would be, how did they make it? More than a century ago, American builders were already manufacturing artificial stone. Engineers were producing cast architectural elements, and industrial technology eventually learned how to take actual volcanic rock, heat it until it became molten, and cast it into new forms. Today we can watch the entire process. Rock, heat, liquid, mold, stone. The technology is real. The ancient evidence, however, is much harder to interpret, and that's where the mystery remains. Because when you stand in front of a massive ancient block, you may be looking at a piece of a mountain, or you may be looking at something that began as a pile of crushed material and was transformed by human hands. We don't know how many ancient stones could have been made this way. We don't even know if the technique was ever used on monumental structures. But there is one question we can test, not with legends, Not with speculation, not with theories, with the stone itself. Was this block quarried or manufactured? And if the answer is hiding inside the stone, perhaps the oldest monuments on Earth have been carrying the evidence all along.